Assalamu alaikum dear students, how are you all? Hope you will be fine. Let's start our today's lecture, boiling point. And previously we discussed about vapor pressure, and now we will discuss about boiling point. When a liquid is heated, its molecules gain energy. We know that the number of molecules which have more than average kinetic energy increases. More and more molecules become energetic enough to overcome the intermolecular forces. Due to this, rate of evaporation increases, that results in increase of vapor pressure until a stage reaches where the vapor pressure of a liquid becomes equal to the atmospheric pressure. So, what is boiling point? Then next definition, boiling point is defined as the temperature at which the vapor pressure of a liquid becomes equal to the atmospheric pressure. It increases with increase in external pressure. For example, if the atmospheric pressure is 2 atm, then we have to provide double amount of heat to attain the internal pressure equal to external or atmospheric pressure. Liquids with greater intermolecular forces have high boiling points, and because greater intermolecular forces mean it has more force of attraction, and that's why it will take time to break intermolecular forces and convert them into vapor phase or into bubble phase. So here it is, next definition. And next, the graphical representation. Boiling point definition. Boiling point is defined as the temperature at which the vapor pressure of a liquid becomes equal to the atmospheric pressure or any external pressure. And next is the definition, and next heading the figure shows. Next heading is graphical representation, in which we discuss about the boiling point and vapor pressure of different molecules or liquids. For example, at 0 degree Celsius, the vapor pressure of diethyl ether is 200 millimeter of mercury. Ethyl alcohol is 25 millimeter of mercury, and that of water is about 5 millimeter of mercury. When they are heated, vapor pressure of diethyl ether increases rapidly and become equal to atmospheric pressure at 34.6. You can see here that at 0 degree Celsius, diethyl ether already have 200 millimeter mercury, already have vapor pressure at 0 degree Celsius. So because it's a volatile, it is volatile, it can easily convert into vapor phase. That's why without any temperature, diethyl ether have 200 millimeter mercury, or ethyl alcohol have 25 millimeter of mercury, and that's why water is about 5 millimeter of mercury. And its mean diethyl ether require less heat to attain 1 atm and 760 torr and 760 millimeter mercury. Or ethyl alcohol will also require more temperature than diethyl ether, because it has 25 millimeter mercury vapor pressure at 0 degree Celsius. That's why it will require more heat than diethyl ether, because its vapor pressure is less, and because water has 5 millimeter of mercury, because water also has intermolecular forces, hydrogen bonding. That's why it's at 0 degree Celsius it has 5 millimeter mercury pressure, atmospheric pressure. So when it require more heat than the diethyl ether or alcohol, because of less vapor pressure. So it will take time to attain vapor pressure equal to atmospheric pressure. You can see here. Here it is the graphical representation. You can see here x-axis temperature, and on y-axis there is the vapor pressure in millimeter of mercury. And you can see here at 20 degree Celsius temperature, 20 and 40, between the 20 and 40, 34.6 is the boiling point of ether. At 34.6, ether will start to boil, because it is also has 200 millimeter of mercury pressure, and only by heating 34.6 degrees Celsius it will start boil. Similarly with alcohol have 50 millimeter of mercury at 0 degree Celsius, and 78 degrees Celsius it will start to boil. its vapor pressure will be equal to external pressure or atmospheric pressure at 78 degrees Celsius. So it will start to boil. And similarly with water, and water is have 100 degrees Celsius temperature, require 100 degrees Celsius temperature to boil, because it has only 5 millimeter mercury pressure, vapor pressure at 0 degrees Celsius. So any liquid when have vapor pressure above the surface equal to the external or atmospheric pressure, it will start boil. Next, factors affecting the boiling point: pressure, molecular weight, structure of the molecules and intermolecular forces, branching, polarity, van der Waals interactions, hydrogen bonding, impurities. These are the number of factors which affect the boiling point, but in our book we will discuss only few, which are nature of liquid, intermolecular forces or external pressure. The polar liquids have higher boiling point than that of non-polar liquid, because polar liquids have strong intermolecular forces. We know that all type of intermolecular forces exist between polar molecules. For example, dipole-dipole interactions, or ion-dipole interactions, hydrogen bonding. So polar molecules have strong due to strong intermolecular forces. So their molecules will get they require more energy and more heat to convert into vapor phase. That's why the polar liquids have higher boiling point than the non-polar. Intermolecular forces play a very important role in the boiling point of liquids. Substances having stronger intermolecular forces have high boiling point, because such liquids attain a level of vapor pressure equal to external pressure at high temperature. It is given in the figure. And we know that water has, due to hydrogen bonding, will attain vapor pressure equal to external vapor pressure at 100 degrees Celsius. So because it has more stronger intermolecular forces, which is hydrogen bonding. Similarly, with the external pressure, boiling points of a liquid depends upon the external pressure. Boiling point of liquid is controlled by external pressure in such a way that it can be increased by increasing external pressure and vice versa. Obviously, if we know that boiling point is the point when the external pressure, internal pressure, vapor pressure or external pressure or atmospheric pressure will be equal. If, for example, if we increase atmospheric pressure will be 2 atm, then we have to provide more heat to attain the vapor pressure equal to 2 atm. So we can control atmospheric pressure. We can control boiling point of any liquid by increasing or decreasing atmospheric pressure. If we decrease the atmospheric pressure, then it will require less heat to boil a liquid. If we increase the atmospheric pressure, then it will require more heat to boil the liquid. So what is the main difference between the vapor pressure and boiling point? Vapor pressure is the force exerted by the vapor released by a liquid or solid substance in a closed container or space. Boiling point is the temperature at which the vapor pressure is equal to the external pressure applied on the liquid. Defined for a closed system with a constant temperature. Vapor pressure, we study vapor pressure with a constant temperature. Maybe we can study vapor pressure at 20 degrees Celsius, 40, 60, 80 and 100 till the boiling point is reached. So in the vapor pressure, the temperature is constant. Related to the both solids and liquid phases varies with the temperature. In which varies with the temperature. Vapor pressure varies with the temperature, varies with the atmospheric pressure, and boiling point varies with the atmospheric pressures, related only to the liquid phase, but vapor pressure related to the both solid and liquid phase. And vapor pressure defined for a system with a constant pressure, and defined for a closed system with a constant temperature. And in this we know that vapor pressure, we can study vapor pressure at any temperature, at constant temperature at 20 degrees Celsius, 40 any temperature. Or boiling point varies with the external pressure. If the external pressure or atmospheric pressure is more, then we have to provide more energy, more heat to attain the boiling point. For example, if the atmospheric pressure is equal to 2 atm, then we have to provide double amount water we have to provide 200 degrees Celsius temperature to boil the water, because at 100 degrees Celsius it will boil if the external pressure will be 1 atm. So by increasing or decreasing atmospheric pressure, the boiling point of any liquid can be changed and varies with the atmospheric pressure. So it is the main difference between vapor pressure and boiling point. And here it is the more examples. Difference between vapor pressure and boiling point. Vapor pressure is equal to, when the rate of evaporation and condensation will be equal, is called vapor pressure. It can be at any temperature, 20, 40, any temperature. But the boiling point is the point in which vapor pressure of a liquid becomes equal to atmospheric pressure and bubbles formation start. And bubbles cannot form since the vapor pressure is less than atmospheric pressure, and bubbles can form and rise since the vapor pressure can overcome atmospheric pressure. And bubbles can start to form if the vapor pressure becomes equal to external pressure or more than external pressure. So here it is the today's lecture. Next we will discuss about diffusion, freezing point, boiling point. After boiling point we will discuss about freezing point and then diffusion. Till then, Allah Hafiz, have a good day.